Hi, this is Lab 2, implementing multiplexers using Simulink. I am in Group 1, so I am simplifying and implementing Equation 1 for both groups. So, as you can see, all my inputs are off, which means the light will be off according to this truth table right here on the screen. If I turn on 1, alpha will turn on. If I turn on B, should stay off. Should stay off as long as D is off, sorry. If I turn D on, the light should turn on as long as B's on. If I turn C on now, it'll rely off of what D's input is, so B and C on. If I turn D off now, it'll turn off. Now if I turn them all on, the light will stay off. If I have A and B on, alpha still stays off. This is the second equation for group 1. So we can see on the truth table right here on the screen that as long as all the inputs are off, the diode will stay off. If I turn C on, I'll have the same result. If I turn B on, the diode should turn on. If I turn B and C on, it will be based off D's input. So if I turn D on, then the diode will turn on. If I turn them all on, it'll stay on. Same thing if I turn only A and B on. Sorry, my LED right here is not working very well. And if I only have A on, then the diode would turn off. This is part 2 of the lab, debugging a given Simulink file. After creating a new truth table, I implemented the correct version using multiplexers and inverters. So as we can see on the truth table on the screen, when all the inputs are off, the output will be off. If I turn C on, then alpha will turn on as long as D is off. So C is on, D is off. If I turn D on, the diode will turn off. If I turn B and C on, then the output will be what D is. If I turn D back on, then it will be alpha. If I turn all inputs on, then you can see on the truth table that the input will always be 1.